Hello there. Welcome to Engineering Drawing Made Easy.
In today's video, we are going to work on the seed tangency problem. Now, this is a bit complicated, but it's not impossible. So, as usual, you have to study the figure carefully and notice all the various lines that you have to draw. Right, these have two straight lines here, which are parallel to each other, distance of 26. You have two arcs or circles here, which are also concentric or let's say parallel to each other. We have this arc here, these two arc here connecting these two, and then we have this one and this last arc here. So try and find all the various arcs or lines and see the relation they all have with each other. Once again, it's always best to start with the easiest and most straightforward parts of the work. So I'll start by drawing this line and the line parallel to it. Yeah, from the dimension, this line has a length of 15, um, 100 and 115 millimeters, yes, and the line parallel to it is at the distance of 26 millimeters. So that's what I'll be drawing. Now, the next simplest figure or easiest thing to do would be to draw this line here, right? This is a center line, and this circle and this circle are both in relation to this particular center line. You can also see that this circle has some sort of relation to this center line. So drawing this center line would be a key step in this work. This center line is at a distance of 13 millimeters from the end of this line. So with with the distance of 13, we draw the center line. Okay, now on our center line here, we can see that this arc of radius 10 millimeters, right, is on this particular line that we just drew and at a distance of 103 millimeters from the base here. So you have this line, you take a look, 103, and then you draw the circle. The next one will be this circle up on here that touches this one at exactly 1 point externally, right? And it's also on this line with radius 8 millimeters. Okay.
If this lesson is helpful so far, don't forget to subscribe so you don't miss upcoming tutorials.
Now that we have this part of the work done, we go on to these two concentric circles which are parallel to each other and also have their center at the same point of origin. Right. This one has a radius of 142, touches this at exactly 1 point, touches this circle at exactly 1 point. Now, I'm facing a challenge here where the issue is that my compass cannot open up beyond 140 millimeters, right? And I need to open up to 142, and sometimes I'll probably even have to go beyond. So yeah, it's occurrence, and that happens sometimes. And I would suggest if you're facing that issue, you would find another compass that can go beyond that. But for this case, I'm going to use a little trick. It's not it's not always advisable, but if you're in need, you could do that. I'm going to extend the pencil to be a bit longer than the pin, and then I'll try again. Yep. Now I can go beyond 14, so I'll make it 42. So like I said, this is always not advisable, right? It's best you go for a compass that can reach to the distance where you want properly. Right. So then for myself, I need to get a bigger compass. Yeah. Now we've got one line that shows us where the center would be. We need another one, and that one will come from the relation between this and this. They touch externally. So from the tangency rule that we know, it has the radius of 10 to the radius of about 42, which equals 152. But my compass will not go that far. So here we use another trick again, and we know that the center has to be on this curve somewhere, right? So we mark out the distance of 152 on our compass, on our long rule, rather. We put that on the center or the point that we want to move from. And then we adjust the rule until we have the zero mark on the arc here, and then 152 millimeters on the center point. That literally tells us that the distance between that center or that point on the arc and then the center of the circle is 152. So that's what we are going to do. Yeah. But if you have a bigger compass, you can um, open it up straight and it should give you what you're looking for. Now, the next arc could be 103 millimeters, right? From the same center. So, first of all, let's fix the compass. Now, the next easiest component you can do is from this point, touching this arc and touching this arc too as well, right? And that also has a radius of 103. So from the point of intersection between this line and this line, that is where the center originates. Yeah, so the only two things remaining will be this arc and this arc. And yeah, basically we're about 80% done with the work. And if you have any thoughts or questions, you leave them in the comment section. I'll get back to you and share with your colleagues as well so that they can also find this video helpful. Now, working on this part of the circle is um, fairly easy compared to what I've been doing so far in today's video. We have a circle here that is touching this particular arc internally and then touching this particular arc externally. So from here you add radius of 7 to this, you try to find the center and then you subtract 7 from this and you try to find the center. So radius of 7 plus 103 give us 110. And then 103 minus 1 minus 7 gives us 96. Now we've already located a center, so with radius of 7 at the center. Now I would encourage you to always try and be careful about your points and then instruments that you use because this is drawing and there's always some slight errors when it comes to the measurements and then the drawing as well. Yeah, there's always some plus 1 or 2 millimeter error, so or minus 1 or 2 millimeter error. So you should be careful and check that, and you also kind of play around it to make the whole thing fit very well. The next thing would be this point, uh, this circle, right? And once again, if you take a look, it is touching this arc internally, right? So the distance here would be this radius 103 minus 16, and then since it's touching this line and exactly at 1 point, it should be the distance from the line, which is 16. Now, so this is to draw a parallel line, um, 60 at a distance of 60 millimeters from the line that we have there at the base. So there you have it. We've been able to replicate this figure. Uh, this figure is a lot complicated compared to what we've been doing so far. So there are a lot of constructional lines and a whole lot of messy lines. I'd encourage you to clean some of the lines that is not part of the work, but if your lecturer or supervisor expects you to show some sort of constructional lines, then you can deepen out the main work and probably leave some of the lines in there. But just clean some of the stuff out and you could have just the work. Yeah. So there you have it. You could spend time, go over the lines again to deepen it and make it look more presentable. So that'll be it for today's video. Kindly subscribe to the channel to support it too and also share with your colleagues. See you next time.